This is part two of the lectures on cell membranes, and we had been discussing diffusion. That's where we left off, is diffusion, where it's a type of passive transport where molecules move from their high concentration to their low concentration um, with no energy required. So, what are the factors that affect the rate of diffusion or how fast diffusion occurs? One is the concentration gradient. The larger the concentration gradient, the faster the diffusion is going to be. So if you have, let's say, here's your cell, and inside the cell is a 1% solution um, of salt or any solute, and outside the cell is a 2% solution of that same solute versus if you have a cell that has a 1% solution and then outside is a 10% solution, diffusion is going to be much, much faster in the second cell um, because the difference between 1 and 10 is greater than the difference between 1 and 2. So the larger the concentration gradient, the faster the diffusion. And then the mass of the molecules diffusing. Now this one is the smaller molecules diffuse faster. The temperature, you probably can guess this one. The hotter the temperature or the higher the temperature, the faster the diffusion. So it's we call that a direct relationship. So when the temperature goes up, so does the diffusion rate, speeds up. The density of the solvent would be most of the time water, but it could also be uh, like cytoplasm or cytosol is more dense than water. It's thicker than water. It's more like a gel. So the more dense that the solvent is, the slower the diffusion is going to be. So the higher the solvent density, the slower the diffusion rate. Solubility. There are molecules that are more soluble in water than others. So when solubility is higher, diffusion rate is higher. And the surface area and thickness of the plasma membrane. The greater the surface area of the plasma membrane, you're going to have faster diffusion because there's more area for molecules to diffuse across. So increase surface area, increase diffusion rate. Thickness of the plasma membrane. The thinner that it is, so decrease the thickness of the membrane, and you will increase the rate of diffusion. And then distance traveled, how far the molecule has to travel when it diffuses from one area to another. The smaller the distance, the faster diffusion will be. Okay. Um, Now, diffusion across the phospholipid bilayer can only happen with nonpolar molecules, like we talked about. Small lipid molecules, or like oxygen gas and carbon dioxide gas, are able to diffuse directly through the phospholipid bilayer. But facilitated transport means that the molecules are diffusing across the phospholipid bilayer, but um, they have to go through a transport protein. So facilitated transport or facilitated diffusion occurs when you have ions or polar molecules that are soluble in water. And so what happens is the ions or polar molecules still move from high to low down their concentration gradient, and there is still no energy involved. This is still a passive process. The only difference is that the molecules or ions have to move through a transport protein. So let's look at one example of a transport protein is a channel protein. And that is literally a protein that creates a hole or channel through the plasma membrane. So if you look at the molecules, I haven't really named them, but the darker green hexagon molecules, they look like glucose, so we'll call them glucose. Glucose would be a polar molecule, so it would not be able to diffuse through the phospholipids. It would have to diffuse through a channel protein. So where do you see the higher concentration of glucose? And that is going to be in the extracellular fluid outside the cell. And then you see a lower concentration of glucose inside the cell. So again, the molecule glucose is going to move from high to low concentration, and no energy is required, but it just needs a channel protein. It cannot go directly through the phospholipids. Okay? A carrier protein is similar to a channel protein, but instead of being open all the time, um, what will happen is the molecule that we're looking at right now is the light green oval. And we can call it an amino acid because amino acids have to go through transport proteins. They are polar molecules. So let's say that it's an amino acid, and we can see that the concentration of these green molecules is higher outside the cell. So what's going to happen is it's going to move into the cell, but what it does is it will bind with the carrier protein first. The carrier protein will change shape and open up and then allow that molecule to pass through and enter into the cell. So still, there is, with the carrier protein, there is no energy required if it's passive transport. It's just that the process is slower than with the channel protein. All right, now another type of diffusion is the diffusion of water. So osmosis is the movement of water through a selectively permeable membrane according to the concentration gradient of water across the membrane. Um, what I always tell my students is you can look at it one of two ways. You can either look at where there's the most water, the water is going to travel where there's the least water. So if you look at water concentration, the water concentration is high on the left and it's low on the right. But you can also say water follows solute. Water goes to where the most concentrated solution is. Water goes to where, because a lot of times salt, S-A-L-T, salt is our solute. Um, Water follows salt. Water goes where it's saltier. So you could also look at that. Water is going to move toward the more concentrated solution. And it will do that until the concentration of those solute particles is about the same on each side of the membrane. So what's going on with osmosis is something called tonicity. Tonicity describes how an extracellular solution, in other words, a solution that surrounds the cell, can change the volume of a cell by affecting osmosis. So we either call that solution hypotonic, meaning its concentration is lower than inside the cell, hypertonic, meaning its concentration is higher than inside the cell, or isotonic, meaning the concentration matches inside the cell. So what happens is, and by the way, osmolarity is another word related to tonicity, and it describes the total solute concentration of the solution. So higher osmolarity is a higher concentration of solute. So if a cell is surrounded by a hypotonic solution, then water will enter the cell because water is going to move where it's more concentrated. The cell can swell and it can also possibly burst. In a hypertonic solution, water is going to leave the cell because the higher concentration is outside the cell, so the cell will shrink. In an isotonic solution, an equal amount of water will leave that comes in, so there won't be any movement, net movement out or into the cell, and the cell will stay the same size. Now here we have a picture of red blood cells, and I want you to look in the middle first. If red blood cells are placed in an isotonic solution, which is what you have with your IV saline solution, whenever you're when you go to the hospital and they give you they just you know, give you an IV so that you can get fluid. They're not going to give you just plain water. They're going to give you a 0.89% saline or salt solution in your IV. Because that is isotonic. That's the same as the concentration of salt inside the cells. So you can see that these red blood cells look nice and healthy, but they're not too big and they haven't shrunk. But if the water is in a hypertonic solution, so let's say that, sorry, not the water, if the red blood cell is in a hypertonic solution, we know the inside is 0.89%. So let's say that outside is like a 2% saline. So that's a higher concentration outside than inside. Water is going to move out of the cell and the cell is going to shrink. And we call this lysis. We call this hemolysis if it occurs in a red blood cell. And then in a hypotonic solution, it will be the opposite. The solution outside the cell maybe is just 0. Inside it's 0.89 saline, and outside it's 0% saline. So it's just straight distilled water. Then water is going to move into the red blood cell and cause some of those red blood cells to burst. We call this, I'm telling you, gosh, I'm doing great today. I'm not going to re-record this though. I'm giving you the opposite words. When the red blood cells burst because they fill up or swell with water, that is hemolysis, because lysis means to break down or burst. So hemo refers to the red blood cell. The word for shrinking in a red blood cell is crenation. I'm so sorry about that. So crenation occurs when a red blood cell is placed in a hypertonic solution and the red blood cell shrinks. Hemolysis occurs when a red blood cell is placed in a hypotonic solution and the cell swells and bursts. Now what you're seeing here is a plant cell. And what you've got to remember is the black outline is the cell wall and the green outline is the plasma membrane or the cell membrane. So in an isotonic solution, the plant plasma membrane is kind of up against the cell wall, but not tightly. The central vacuole is filled with water, but it's not. It's still giving room for all the other organelles, in the cell. So the cell is not really swelling and it's not shrinking. But if the plant cell is placed in a hypotonic solution, such as uh, distilled water, which has nothing dissolved in it, no solute, so it would be a 0% concentration. Water will enter the plant cell. It's not going to burst, but the plasma membrane is going to be pushed up against the cell wall, and the central vacuole will almost take up all the space inside of the cell, and it'll push the organelles up to the sides, right up against the cell wall. So we call this, when this happens in a plant, we call it turgor pressure. And the opposite of this is when the plant is placed in a hypertonic solution. It does shrink, but basically the plasma membrane shrinks away from the cell wall. The cell wall does not change size. And so that's what you see happen in a plant cell that's placed in a hypertonic solution, where where the solution has a higher concentration than what's inside the cell. And by the way, we call this plasmolysis.